So I'm now live. I see 4 people there. Brilliant. If you just, there's 3 now, so someone dropped out. If you just say hi there in the chat window. Okay. I'm going to mute. Will I mute myself on Teams because I'm on YouTube now? Okay. Maybe I'll just post that there now for everybody. Just one other second. So I have 8 people here now. Brilliant. Oh, excellent. Excellent. Okay. Hi, Shivra. Hopefully I pronounced your name right. Jessica, hi. Hi, Lena. Hi, Marilyn. Hi, Sophie. Hi, Harif. Hi, Chelsea. Brilliant. Okay. 2, 4, 6, 7. There's about 8 or 9 people there now. Okay. So let's maybe just get this going here. So there was a question that was asked here, which is in relation to how to calculate the standard deviation. Now, it depends on whether, once again, I'll just focus this in here for a moment. Just give me a second so that I focus this in. Okay, brilliant. That's focused now by the looks of it. Great. So it depends on whether we have discrete data or whether we have, I'm just trying to find an example here because I just want to see whether Gerard is asking it from a discrete data perspective or not. Okay, so let's just see here. You should have an example here somewhere. And okay, so what we have is we have a group frequency distribution, and we also have, okay, with the raw data. Yeah, okay, so what I'll do is I'll do it from the raw data perspective. Can you mute on Teams because it's like an echo? I can do that, yeah, definitely. So I'm just going to mute. I muted, so someone muted me already there. Okay, Sophie, did you mute me on Teams? Did you? Thanks very much. Okay, so the question that we have here is how do you calculate a standard deviation? Okay, a standard deviation. That's a question that we have. I suppose there's going to be 2 ways. I'll do it both ways. Okay, the first way is using raw data. Okay, raw data. Okay, and the second way is using a grouped frequency distribution. Okay, distribution. So let's have a look at both ways. Yeah. Okay. So in the raw data case, the formula for the standard deviation, well, the formula for the variance. Okay. The variance, which is, now once again, it depends on whether we're dealing with sample or whether we're dealing with population data. Okay, so that's an important thing. So let's just assume that we're dealing with sample data. Okay, sample data. It should be very clear in the question. Okay, so if we're dealing with sample data, S squared is equal to, it's the sum of the observations, the x's, minus the x bar, the mean of the observations, and you square that all over n minus 1. Okay, that's the formula to calculate the variance. So that's for the variance. Okay. The formula to calculate the standard deviation is just the square root of the variance. It's S. Just bear with this for a moment. I'll show you how these formulas are implemented now in a moment. S is equal to, it's simply the square root of this number here. So it's the sum of the x's minus the x bar squared all over n minus 1. And it's the square root of that. Okay. So Gemma, I just want to just say something here. Hi Gemma. Gemma, we've moved across. We've moved across to YouTube. Okay. Click on the URL above. Okay. So okay. So let's say, for argument's sake, that we asked 5 people how much did they spend over the weekend. Okay. And let's say that the results. Okay. So how much did you spend? How much did you spend? And let's say the responses were, let's say for argument's sake, the responses were, the first person said 10 euros, the next person said 15, let's say 22 euros, let's say 35 euros, and let's say for argument's sake, we had 18 euros. Okay. So these are the results, not the results, these are the, let's say, the responses from the question that we asked, the variable that we're measuring, how much did you spend. Okay. And what we'd like to do is we'd like to calculate the standard deviation of this particular data set. So the first thing that we're going to do, okay, is we're going to just rewrite the data in a table. Okay, so I'm going to put it in a table. These are our observations. These are our X values, our observations, and we're just going to list them down: 10, 15, 22, 35, and 18. Okay, so we're just going to create a table really quickly. Okay, and then what we're going to do is we're going to calculate. We're going to, if I can just find where the hell is my calculator gone to? Okay, what we're going to do is we're going to calculate the mean of these. So to calculate the standard deviation, we have to calculate the variance first. And what we need is we need to calculate the mean of the observations. Okay, so the mean of the observations, X bar. Okay, so X bar is simply the sum of all the observations divided by how many there are. So in this case here, it's going to be 10 plus 15 plus 22 plus 35 plus 18 divided by 5. What does that give us? That gives us 10, 20, 40, 70, 80. Okay, that gives us 80, 90. That gives us 100 effectively. So now we have, that's 100 over 5. So when we divide that in, we end up with a mean value of 20, if I'm not mistaken. Okay, so out of these 5 responses, okay, you can see that everybody had a different response. Okay, out of these 5 responses, the average response is 20 euros. Okay, from asking the question, how much did you spend over the weekend? The average of this sample, okay, is 20 euros. Okay? Now, what we can also see is that you should have access to the formulas. Yeah, I'm sure. Yeah. Okay. So what we can also see here is that each observation is either less than the mean or it's greater than the mean. Okay, so you can see that we have we have 3 observations less than the mean, and we have 2 observations above the mean. But every observation is a little bit of a distance below and above the mean value. Okay, so what we effectively want to calculate is the average distance that people are above and below that value. Okay, and that's what the standard deviation does for us. Okay? But to do it, we're going to go through the variance, and you can see from the formula in the variance formula here. The denominator is n minus 1. It's the sample size minus 1. Okay, so n is the sample size. Okay, and in our case, we've got 1, 2, 3, 4, 5 observations. So n is equal to 5. So it's 5 minus 1 gives us 4. So we have half the formula already. Okay. Now, then we have to calculate the numerator, yeah, which is saying you need to sum up the distance between each observation and the mean value, and actually sum up the squares of those. So let's just do this in stages. So what we're going to do is we're going to take each observation and we're going to take away the mean value, okay, and see what we get, okay, first of all. So this question here, where am I going to? Sophie, yeah, okay? We're doing it in stages. If you want to calculate the standard deviation for a sample, your table is always going to look something like this. So don't forget, X bar is 20 and it doesn't change. So my first X is 10, and then I have to take away X bar. So it's 10 minus 20 gives us minus 10. The next X is 15, and what we're going to do is take away 20, which gives us minus 5. The next X is 22, and I'm going to take away 20 from that, which gives us 2. Then we have 35 minus 20, that's going to give us 15. And then we have 18 minus 20 gives us minus 2. So really what we have here is actually these are the distances that each observation is away from the respective mean values, if that makes sense. So what we need to do is we need to now calculate the square of those distances, okay? So we need to calculate x minus x bar squared. So we need another column here called x minus x bar squared. Okay? This is just a process. So you can see that 10 squared is going to be 100. 5 squared is going to be 25. 2 squared is going to be 4. 15 squared is going to be a value of 225. And minus 2 squared is also going to be 4. So now what we have is, you see the summation is followed by a label, x minus x bar squared. And now we have a column in our table called x minus x bar squared. So what we need to do is we need to sum up that column. Okay. So what we have is 100 plus 25 plus 4 plus 225 plus 4 gives us a total summation of 358. So this value here is effectively the sum of the column called x minus x bar squared. Okay, So now what we can do is we can actually calculate the variance. Okay, let me just move this across here. No, this video is recording, guys. So I will make it. I will make a lot. I will give you access to it now later on. Yeah. So what we have now is the variance. The variance. Right. It's s squared is the sum of the x's minus the x bar squared all over n minus 1. So in our case, s squared is equal to the sum of the x minus the x bar squared is 358. N is 5, the sample size, minus 1. So that gives us 358 over 4. And we just do the division, okay? So it's 358. So we have 358 divided by 4. And that gives us a value of 89.5. So it's approximately 89.5. That's the variance, okay? Now, Sophie, you wanted to know how to calculate the standard deviation. But the standard deviation is just the square root of the variance, okay? So let me rewrite that down again. So the standard deviation, the symbol for the sample is S. It's equal to the sum of the x's minus the x bar squared all over n minus 1. And it's the square root of that. So S is simply equal to, we've already calculated what's inside the square root here. Okay, that's this thing here. We've calculated it. Okay, it's 89.5. So what we need to do is calculate the square root of 89.5, which is going to be approximately equal to, so I'm going to go the square root of 89.5, and that gives us a value of, it's about 9.46. Okay, so that would be how to calculate the standard deviation. Sophie, does that help you out with the standard deviation? Okay. I'll just wait for Sophie there. Okay. Okay, brilliant, Harif. Thanks, Nicole. Brilliant. Okay, I just want to do just one other calculation here, okay? Because what we were dealing with here is we were dealing with raw data, okay? So let me just change things around a little bit, and let's just assume that what we have is a group frequency distribution, okay? So it is possible that he could ask you in relation to a group frequency distribution and how to calculate the mean, the variance, and the standard deviation. So I'm just going to pull one out of the sky. So this is what it looks like. Let's say here now we have our spending, okay? The spend, let's say it was between 0 and 20 euros, 20 and 40, 40 and 60, and let's just keep it simple, 60 and 80 euros, okay? And here's the frequencies, okay? And let's say we have 2, 5, 3, and 1, which gives us a total, of 11 here, okay? So really what I'm saying here, Sophie, okay, in this particular case here, okay, which is different to the raw data case. The raw data case is where you have the actual values, yeah, okay? So in this situation, I asked 11 people the question, okay? I asked 11 people the question. That's the sum of the F's there, okay? That's the sum of the F column. So that's sigma F11, yeah? I asked 11 people the question, and 2 responded with a value between 0 and 20 euros, yeah? 5 with a value between 20 and 40, 3 with a value between 40 and 60, and 1 with a value between 60 and 80. Now, the convention is that numbers that include responses that include the lower bound but exclude the upper bound are counted within the intervals. Yeah. So if someone responded with a value of 20, they'd actually be counted in this interval here. If someone responded with a value of 40, they'd be counted in here. So it excludes the upper bound. So what we'd like to do now is that we'd like to calculate the variance or the standard deviation in this particular case. Now, the formula for the variance, okay, is still s squared, but this time we've got frequencies. So it's the sum of the frequencies times the x minus the x bar squared all over. It's over n, but n is the sum of the frequencies. So it's the sum of the frequencies also minus 1. Okay? And x bar, if you want to calculate x bar is simply equal to, now, don't forget, we don't have the responses just yet. So it's the sum of the frequencies times the responses divided by the sum of the frequencies. So before we can calculate the variance, we need to calculate X bar. And to calculate X bar, we need to have frequencies and X's, observations. But we don't have the frequency. We have the frequencies, but we don't have the actual observations. We have the intervals. So what we'll do is we'll choose the observations ourselves. Okay, we'll select the midpoints of the classes. Okay, so we'll do the midpoints. And the midpoints are simply the lower bound plus the upper bound divided by 2. So 0 plus 20 gives me 20. Divide that by 2 gives me 10. So I'm going to assume that these two people responded with a value of 10. Then we have 20 plus 40 gives me 60. Divide that by 2 gives me 30. 40 plus 60 gives me 100. Divide that by 2 gives me 50. 60 plus 60 plus 80 gives me 140. Divided by 2 gives me 70. So we're going to assume that these two people responded with a value of 10. These 5 all responded with a value of 30. These 3 all responded with a value of 50, and so on. Okay? And now we can calculate our mean value. Okay? To calculate the mean, we need the sigma f, the sum of the f's. Well, we have that there, the sum of the f column, that's sigma f. But we also need the sum of the fx column. Now, just keep in mind in maths, when we want you to add, we'll use a plus sign. When we want you to divide, we'll use a bar. Subtract, we use a minus sign. If we want you to get a square, we'll use a square sign. A square root sign we'll use if we want to get a square root. But when we want you to multiply things together, we don't use a sign. We just juxtapose the symbols together. So fx effectively means the f column multiplied by the x column. Okay, so it's 2 times 10 gives me 20. Okay, so it's 2 times 10 gives me the 20 here. It's 5 times 30. It gives me 150. It's 3 times 50 gives me 150. And it's 1 times 70 gives me 70. Okay. Now we need for the mean, I'll just cross this over here. Sorry, guys. Okay. For the mean value, okay, to calculate the mean, we need for X bar, it's the sum of the F's times the X's over the sum of the F's. Yeah. So we need the sum of the FX's. Yes, we need to sum up this column here. So it's, you can see 150 and 150 is 300, and the 70 is 370, and the 20 is 390. So this 390 is the sum of the FX. So that's the sum of the FX's, yeah. So now we have both of our values that we can use to calculate our mean. So now we have the mean must be equal to 390 divided by 11. And when we have a look at that there, we end up with a mean value of 390 divided by 11 gives us a value of, it's approximately 35.5. So let's just call it, it's approximately, well, around it to a whole number. X bar is approximately equal to 35. And I'm just going to a whole number here to make things a little bit handier for myself. Yeah. So now that we have, now that we have our X bar, we can proceed to calculate. We can proceed now to calculate our variance. Yeah. Keep in mind, so the variance, right, is S squared is the sum of the F's times the X's minus the X bar squared all over the sum of the F's minus 1. So once again, we have half the formula already. We know the sum of the F's is 11. So we'll have 11 minus 1 here. The denominator is effectively going to be 10. So what we need to do is we need to calculate this top piece here. And like in our previous example, okay, we did X minus X bars followed by X minus X bar squareds. We're still going to do that. Okay, so let's do that here. So we're going to calculate our X minus our X bars. Okay, so what we're going to do is for each X, this is the observations. These are let's say, our representatives of the class that we chose a moment ago. We're going to take away 35. So the first one is 10 minus 35 gives us minus 25. The next one is 30 minus 35 gives us minus 5. 50 minus 35 gives us 15. And 70 minus 35 gives us 35. Okay. Hopefully that's okay for everybody there. So now what we have is we have the distance that the observations are away from the mean. Now we need to square them, okay, because we have effectively this part of the formula here, okay. So now what we need to do is square them. So that's what we're going to do, X minus X bar squared, okay. So we're going to it's going to be 25 squared. Don't forget, negatives times negatives are positive. So we're not going to worry about that. 25 squared is 625. 5 squared is 25. excuse me, we have 15 squared is 225, and then we have 35 to be squared. It's going to be a value of 1,225. Okay. So now what we've calculated is x minus x bar squared. So now what we need to do is we need to take that column and multiply it by the values in the F column. Okay. So I just need to open this up a little bit more. Okay. So what we're going to now do, okay, is we're now going to create another column, our final column, when we're dealing with group frequency distribution. We're going to take our F values and multiply them by the x minus the x bar squared values. Okay. So we're going to have 2 times 625 is going to be 1,250. We're going to have 5 times 25 is 125. We're going to have 3 times 225 is 675. And then we're going to have 1 times, so the value's in here now, it's 1 times this to give us this value here, which is 1225. Point being, we now have, for every observation, we now have the F times the x minus the x bar squared. So what we need to do now is we need to sum those guys up. Okay, so we're going to sum those guys up here, and I'll just use the calculator to do this really quickly. So we have 1250 plus 125 plus 675 plus 1225, which gives us a value of 3275. That's 3275. This value here is the sum of the frequencies times the x minus the x bar squared column. Okay, that value right here now that we just calculated. So now we can calculate our variance. So now S squared is, well, it's a sum of that column, the sum of the frequencies times the x minus the x bar squared column, which is 3275, which needs to be divided by the sum of the frequencies, which is, there's the frequency column, the sum of the frequency column is 11 minus 1. So that's going to be divided by 10, which gives us 327.5. Okay, and the standard deviation, right, is simply the square root of the variance. Okay, so the standard deviation is S, and it's equal to the square root of the variance. Okay, so I'll write the formula down. It's the sum of the f's times the x minus the x bar squared divided by the sum of the f's minus 1. And it's the square root of that. But we just calculate this piece in here, Sophie. Yeah, we just calculate it up here. It's 327.5. So we have to calculate the square root of 327.5, which gives us a value of the square root of 327.5 is approximately 18.1. Okay, so the answer here, this is approximately equal to 18.1, and that's the standard deviation. So you can actually see, if Gerard is going to ask you to calculate the standard deviation, he's going to get a number of things for free. Yeah, he's going to be able to figure out whether you can calculate the mean value. He's also going to be able to figure out whether you can calculate the variance. And then finally, once you have the mean and the variance, well, you need the mean to calculate the variance. Then just getting the square root of that is going to allow him to see that you can actually calculate the standard deviation. Okay, so that's 2 ways to calculate the standard deviation. In the sample paper that was provided, okay, if I'm not mistaken, let me just have a look through here. If I'm not mistaken, we had raw data. Okay, calculate the range. Let's see. I'm just going through this here. That's to calculate the median, the mean, and to calculate the standard deviation. So there's an example in the sample multiple choice questionnaire that gives you raw data and asks you to calculate the standard deviation. That's what we did first. Okay, that was the first thing that we did. Okay, just moving along and just to see whether there's one that uses a group frequency distribution. Maybe there is, maybe there isn't. Okay. So the group frequency distribution, well, here's the group frequency distribution. And there's only really 2 or 3 questions on that. There's no question. Oh, it does ask you here in question 21 to calculate the variance. Okay. Now, to calculate the variance would have been the step before what we just done. Okay, don't forget we've already calculated the standard deviation in their case. So I think it would make sense for Gerard maybe to take the next step, which is actually to provide a question that actually asks you to calculate the standard deviation. The sample paper asks you to calculate the variance. So in that case, it would have been 327.5. Okay. Okay, guys. Sophie, is that okay? Okay. Okay, guys. Are there any other questions? I'll just type that in there just in case people can't hear me. Are there any other questions? That here. Okay. Have you any more questions? Okay. I'll just give this a moment here, yeah, just to see whether there's any more questions coming through from you. Okay, guys, can you hear me okay? Are there any other questions from you? I mean, I can take any questions from you. Guys, can you hear me okay? There doesn't seem to be any questions coming forward here from you. Okay. Maybe I'll just go down through you here. Hi, Gemma. Just wondering whether you have any questions. If you have a question, maybe you can just type it into the chat window. Alternatively, guys, you can email me a question later, yeah, and I can answer the question maybe through email. Hi, Luke. Do you have any questions? Shivra, do you have any questions? Jessica, any questions there from you? Okay. Charles, have you got any questions? Patience? Marilyn? Saeed? Lena? Any more questions, guys? Okay, there's Gemma. Could you go over multiplication rule for probability, please? I can indeed, yep. Okay. So let's just have a look at that there. Okay. Okay. Let me just have a look at his sample paper, yeah. I can't see him changing things, you know. I don't think Gerard would, you know, I think this is a good representation, yeah, in relation to what you should be expecting in the exam itself, yeah. Let's just have a look in here because I know that there is a table here. Here's a table here that he provided, yeah. Okay, which is in relation to the number of houses sold in each month in 2016 by county. Okay. So let me just maybe write down the multiplication rule first of all, Gemma. Okay. So I'm just going to take Gemma's question first of all, and then Harif, I'll have a look at yours in relation to the class intervals. Okay, right. So the multiplication rule. So let's say from a probability perspective, probability, okay? Don't forget our rules are something like this. The first rule is that the probability of an event is simply equal to the number of favorable outcomes, right, divided by the number of possible outcomes, yeah? Okay. And then we have what's known as the addition rule, which says that the probability of one event or another event happening is simply equal to the sum of their probabilities. So it's the probability of the first event plus the probability of the second event. Okay, that's when they're mutually exclusive. Okay. The next thing is then we have the probability of A or B when they're not mutually exclusive. In other words, they share something in common, is equal to the probability of A plus the probability of B minus the probability of A and B, the joint event. So that's the joint event. Okay, that's when A and B happen simultaneously. Okay, so Gemma, your rule is about the multiplication rule, so I'm assuming we're past all of this. Okay, so what I'm going to look at just really quickly is the multiplication rule itself. So the multiplication rule. Okay, and I'll use an example. So the multiplication rule, there's two versions of it. Okay, the first one deals with independence. It says that the probability of A and B, okay, is simply equal to the probability of A times the probability of B when both events are independent of each other. Okay, and we'll have a look at an example now in a second. Yeah, the second version of it says that the probability of A and B is still the product of the probabilities. It's the probability of the first one, okay, times the probability of the second one. But let's just keep in mind that the first one happened, if that makes sense. Yeah. Okay. So this is when they're dependent on each other. And you'll see an example now in a second. Yeah. So let's say, for argument's sake, yeah, let's say a jar, okay, let's say a jar has 4 red marbles, okay, let's say it has 5 blue, okay, and let's say it has 2 green marbles, okay. And what we're going to do is, well, let's just actually work off this and actually just do some probabilities first of all, yeah, okay? Some straightforward probabilities. So let me just write this down again. So let me just keep the probability rules here like this. Yeah, okay. So let's say the jar has, what did I say? I said 4, 5, and 2. Okay, so it has 4 red. Okay, it has 5 blue, and it has 2 green marbles. Okay, just keep it simple. Yeah, or they're in a bag, they're in a jar, and they're let's say they've been shaken. Yeah, so that they're mixed up, if that makes sense. And what we want to know is, if we select a single marble, okay, if we select a single marble, okay, and I want to know what is the probability that the selected marble is, let's say, blue, okay. So to write this down, yeah, from a probability perspective, what we're interested in is calculate what's the probability that the selected marble is blue. Okay, that's how I write that down. Okay. And Nicole, I'll get to that now in a moment. Yeah, question 14. Yeah, okay. So what's the probability that the selected marble is blue? Well, the basic rule says it's the number of favorable outcomes. Well, how many blue marbles are there? There are 5. So there's 5 chances of getting a blue marble out of the number of possible outcomes. And the total number of things in the jar is 4 and 5 and 2. So the total number of things in the jar are 11. Yeah. So the probability of getting a blue marble, okay, is equal to 5 divided by 11. So we have 5 divided by 11, which gives us, from a decimal perspective, it's 0.45. You have a 45% chance of getting a blue marble. Okay? So you can see I could actually ask a different question. I could say, what's the probability of getting a red marble? Okay, the probability of getting a red marble. Now I'm assuming that I'm starting back at the start where all the marbles still in the jar. Okay, That's important, and this is an important thing when it comes to independence, independence and dependence later on. So the probability of a red marble, well, there's 4 red marbles, so you have 4 chances out of 11. The probability of getting a green marble, okay, green, well, there's 2 green marbles, so you have 2 chances out of 11, yeah? Okay? So that's how simple the basic probabilities are, okay? Let's have a look at the addition rule, okay? So what's the probability that the marble I get is green or the marble that I select is red, right? Now, the addition rule says, irrespective of whether they're mutually exclusive or not, okay, it says add the 2 probabilities up, okay? So actually this now becomes the probability that the marble is green plus the probability that the marble is red, okay? And possibly minus a joint event if they're not mutually exclusive, yeah? So what does it mean to be mutually exclusive? It means that these things here have the same condition as these things over here. Now, other than them being marbles, yeah? Well, these things here are green. Them things here are red. Green things aren't red things, if that makes sense, okay? So they are mutually exclusive. So it's the first version of the addition rule. So this just becomes, well, the probability of a green marble is 2 chances over 11, plus the probability of a red marble is 4 chances over 11, which gives us 6 chances in 11 in total. Yeah, right. If I had have added in some other things here, let's say that there are 3 green, half red marbles, yeah, okay. Well, then the probability of getting something that has green color, yeah, okay, and something have a red color, there would be things shared here, okay, and we'd be into the second version of the addition rule, okay. But what I want to do is, because it's for Gemma, is to look at the multiplication rule, and let's have a look at that, okay. So let's say 2 marbles are selected, okay. Now I'm going to ask you, yeah, what is the probability, okay, that the first marble is red and the second marble is red, okay? So that's my question. So we're selecting 2 things now, Gemma, okay? And we want to know what's the probability that the first thing is red and that's the key thing here. The word and is being used. A moment ago, okay, I was asking what's the chances of getting green or red. That's the addition rule, okay? When we use an and, we're in the multiplication rule. So as we know, there are 2 versions of the multiplication rule, okay? The first version is when the events A and B are independent of each other. And the second is where the events A and B are dependent on each other. What the hell does that mean? Yeah. Okay. Well, let's think about it like this. Yeah. Is that when I select my first marble, okay, the probability of getting a red marble, just in general, I've got 4 chances out of 11, okay, because there's 11 marbles. So I have 4 chances out of 11 because all the marbles are still in the tin. Yeah. Now, if I put that marble back in the tin, there's still 11 marbles in the tin, okay? So when I select my second marble, knowing that I put the first marble back in, there's still 11 marbles in the tin, so I've still got 4 chances out of 11 to get another red marble, if that makes sense. So if I hadn't have put the first marble back in the tin, there would be only 10 marbles left in the tin, okay? So that action of not putting the marble back in the tin changes the probability of the second event. Okay, so let's have a look at that. Okay? So I'm going to do 2 cases, okay, for this question. Okay, we'll just have a look at 2 cases. Okay. Case 1 is with replacement. Okay, keyword with replacement. Okay, and I want to calculate what's the probability that the first marble is red and the second selection or the second marble is also red. Okay, but when I select the first one, I put it back in the jar. Okay, so what I know now is this: is that when it comes to the second selection, all my marbles are still in the jar. So we haven't changed the sample size, sorry, the sample space. The sample space still has 11 items in it. So in this case, they're independent. So these 2 things are independent of each other. Independent. Okay, so now it's just the product. now it's just the product of the two probabilities, yeah? So this becomes the probability that the first is red times the probability that the second is also red. Now, the probability that the first is red is, well, how many red marbles are there? There are 4 red marbles out of 11, so it's 4 over 11, times the probability that the second is red. Well, how many red marbles are there in the jar? There's still 4 of them in the jar, and all the marbles are still there, so it's 4 over 11, okay? In which case, what we have is, that gives us 16 chances in 121, okay? From a decimal perspective, when I divide 16 by 121, what I end up with is, I end up with 0.13. So you have a 13% chance of that happening. Okay? Let's do the second case, okay? Case 2. Okay? This time, in case 2, it's without replacement. Okay? And what I want to calculate is the probability that the first is red, and, keyword and is the multiplication rule, and the second marble is also red. Okay? So, because we know it's without replacement, after we take the first marble out, okay, well, the probability of getting the first marble is still, don't forget, there's 4 marbles that are red. There's 4 chances out of 11. Okay? But we didn't put the first marble back in the jar, so there's only 10 marbles left, and in particular, we didn't put a red marble back in, so there's actually only 3 red marbles, yeah? So the probability of the second one then is 3 chances out of 10. So just to write that down mathematically, this becomes it's still the product rule, it's the multiplication rule. The probability that the first is red times the probability that the second is red, knowing that the first was red and wasn't put back in the jar. So this piece here is only a piece of information. It's not mathematical, yeah, here, yeah. It's just saying calculate this probability as you would normally. But don't forget, this thing here wasn't put back in the jar, and it was a red thing that wasn't put back in the jar. So in our case now, what we end up with is the probability that the first is red. Well, there's 4 reds out of 11 times the probability that the second is red. Well, there's only 3 reds left because the first one wasn't put back in the jar, and there's actually only 10 marbles in the jar. So that gives us 12 chances out of 110, right? I could change it around. We could ask any other question. The thing that you're always trying to keep in mind. Let me just get another pen here. Okay? The thing that you're always trying to keep in mind is, when it comes to the multiplication rule, is whether there's replacement or without replacement. Now, it doesn't have to really say that. Sometimes the context of the questions can be quite complicated, but effectively, that's how you calculate how you apply the multiplication rule. Gemma, does that help you out? Okay. Maybe you can reflect back over that now yourself, yeah, later on, yeah. So Gemma, hopefully that cleared that up a little bit for you, yeah. Nicole, I'll get to your question now in a moment, yeah, which is in relation to question 13. I just want to go back to Harif did ask a question earlier on. Yes, I suppose, did you ask 2 questions, Harif? Yeah, you did. Harif says, do we have access to the formulas during the test? Yeah, it's not. This isn't a question about learning off formulas. So yes, you'll have access to the formulas. I don't know whether he's going to provide it to you, yeah, okay. But you probably need to download the formula booklet anyway, and I can probably email it around to the class, yeah, so that you actually have a copy of it. Harif then asked another question, which is, could you go over class intervals? Yeah. Class intervals. Well, I suppose, just maybe when that comes, I think what you're asking here is in relation to constructing a group frequency distribution. Okay, frequency distribution. Now, the thing about it is, he was not going to ask, well, I don't know, because I haven't seen the exam, but it'd be hard, because it's multiple choice, it'd be a hard one for him to ask you to construct a group frequency distribution. But maybe it could be done. But look, maybe I think it'd be probably a bit difficult to ask that in a multiple choice question. Okay, brilliant, Gemma. Just got your response there. So in constructing a group frequency distribution, we have, don't forget, we have classes. Yeah, these are the classes, okay, or the intervals, okay. And there's two questions we need to ask. Is the first question is how many of these things do we have or do we require? Okay, so the number of classes, right, or the number of intervals. And then the second question is the width, is how wide should the intervals be? Okay, so Harif, we have a rule. It's called the 2 to the power of k rule, okay, which allows us to calculate the number of classes, that we require. Okay, and the first thing you have to keep in mind is your sample size n. Okay, and then we have a table for 2 to the power of k. So the possible number of classes are listed down here. You could have a distribution of 1, 2, 3, 4, 5, or 6 classes, and so on. We're just going to calculate 2 to the power of k. When k is 1, 2 to the power of 1, 2 to the power of 1 is 2. When k is 2, 2 squared is 4. When k is 3, it's 2 to the power of 3 is 8, 16, 32, 64. Okay. Now the key point here is that we take our sample size n and we look down this column. We inspect this column of numbers here until we find the first number that exceeds n. Yeah. So for example, if our sample was equal to 17, our sample size, well, the first one that exceeds 17 is 32. So what we'd need is 5 classes. So that has 5 classes. Okay. If our sample size was 46, well, the first number here that exceeds 46 is 64. We'd need 6 classes. 6 classes. Okay. If our sample size was equal to, let's say 4, okay, well, then the first number here to exceed 4, not 2, 4 doesn't exceed 4, 8 does. We'd need 3 classes. Okay, so Harif, hopefully that helps you out. That's how we calculate how many classes we require. What about the interval widths? Well, to calculate the widths, okay, the width is equal to the range effectively divided by the number of classes. Now, typically, we add on a little kicker here, okay? Let's say a kicker, which is typically 1, just so mathematically, so that we end up with appropriate intervals, yeah? So actually, the width of a class is equal to the range of the data set plus 1 divided by k, okay? And then we round that thing up to the nearest whole number. Don't forget the range of the data set is the largest value minus the smallest value. Okay, so the width of our classes in a frequency distribution, in a group frequency distribution, it's pretty easily calculated. You calculate the range of the data set, you add 1 onto it, and then you divide by the number of classes. But to calculate the number of classes, you need to know the sample size. Once you know the sample size, you go down through this table. It never changes, this table. You find the first number in this column that exceeds your sample size. Okay, and that then tells you how many classes that you require. Okay, Harif, I'm hoping that helped you out there in relation to calculating how many classes and also the widths of classes. And Nicole, I think I can answer your question now. Well, I can have a look at it and hopefully answer it. Where am I going to? I'm just going to get the paper across here. Okay. And I'm going to question 14. Okay. Question 14. So look at question 9. 14. Okay. And we did this there the other day. There is a video up online in relation to this. We went through every question on this sample paper the other day, a live stream. I recorded it. It is up on the YouTube channel, that video. And I'd highly recommend actually just playing back through that. Yeah. But anyway, and Nicole, you asked a very valid question there, which is to have a look at question 14. And it says, question 14 is, which of the following is not an example of discrete data? Okay. So don't forget, the data that we capture is always responses to questions. Yeah. Okay. So anytime you ask somebody a question like how many, okay, how many brothers and sisters have you got? Okay. Anytime you have the response where it's a whole number, okay, It's not a decimal number, it's a whole number. That data is what's known as discrete data. Okay. Now, this question is asking which of the following is not an example of discrete data. Okay. So you can see the number of households with a broadband internet connection. If I was to ask you how many households on your road have a broadband internet connection, now you'd probably say all, but there would be a specific number. You'd have to count them up, and you couldn't say that half a house has a broadband connection, yeah, okay, or a quarter of a house. Unless the broadband doesn't broadcast up onto the third or fourth floor if you have a 3 or 4 story house, okay? But the number of households is a whole number, yeah? So that's discrete data. The number of employees reporting in sick. How many people were reporting in sick last week? Well, that's a whole number, okay? The number of students in NCI, that's a whole number. We don't have half a student, a quarter of a student, yeah? Okay, they're all whole numbers, except for C. The number of kilometres between Dublin and Cork. Now, because the number of kilometres between Dublin and Cork is probably something like, I don't know, 215.6 kilometres, if that makes sense, yeah? Okay. So, Nicole, the key thing here is that discrete data, okay, discrete data is where there's, I suppose, I want to be technical about it, okay, technical about that question. Maybe I'll just get back to that because it doesn't necessarily have to be just a whole number, okay? The number of pennies, yeah, okay, discrete data, yeah, is that here's a scale, okay? The variable could be anything, yeah, okay? Discrete data is where the responses to the questions, yeah, okay, that when you take any two responses that are very close together, yeah, okay, that there's no other valid response between them, yeah, okay. Once you have that scenario, well, then that's what's known as discrete data, okay. If you think about time, okay, this is, let's say, 5 minutes, this is 10 minutes, this is 15 minutes, yeah, okay. So this is time, okay. This is 0 minutes. Well, between 5 and 10 minutes, there actually is more time, if that makes sense. There's 7.5 minutes in there, yeah. So the point I'm trying to make here is that discrete data, if I can get 2 points that have a gap between them and that a response in the gap doesn't make any sense, well, then that's discrete data. Otherwise, the data you have is continuous data. I don't know whether that helped out. One way to sort of figure it out is if the response to the question are whole numbers, typically it's discrete data. And for you guys, that's really going to be the judgment, the rule that you need to use to really identify it. Technically, it's got to do with I can find 2 points that are very close together and that there's a gap between them. And that if someone responded with something in the gap, a number from the gap, it doesn't make sense, yeah? Okay. Nicole, hopefully that helped you out there. That was in relation to question 13, Nicole. Okay. Was the one with the battery. Sorry, Nicole, I'm at to be going through that there. Yeah. So let me get rid of that there now. Okay. The one with the battery. Okay, so let's have a look at that. And once again, the video that I did the other day, I did go through this in a lot of detail. So this is at the end of the paper, I think. So it's not the question 13. Okay, I think we're talking about question 29 and we're talking about question 30, okay, if I'm not mistaken. Okay, so what's the probability of selecting 3 defective batteries? Yeah, okay. So question 30, not 13. Okay, sorry, Nicole. Yeah. So question 30, the probability of selecting 3 defective batteries. Okay. That's what we want to calculate. Yep. So let's just have a look at the scenario. It says there are 10 AAA batteries in a box and 3 are defective. Yeah. So we have 10 AAA batteries. Okay. We have 7 are good and we have 3 are defective. Okay. Defective, effectively. Yeah. And what we know is 2 batteries are selected without replacement. Okay. What is the probability of selecting 3 batteries? Okay, what is the probability of selecting 3 defective batteries in a row? Okay, so the first 2 were selected without replacement. Brilliant. So now, see, now what we have is we have dependence coming into play. Yeah. So what we're interested in is the probability that the first is defective and the second is defective and the third is defective. Okay. So, because that's what we need. We need 3 batteries. The first has to be defective, the second has to be defective, and the third defective. Keywords are "and" here, yeah, okay, which is the multiplication rule, yeah. So this effectively now becomes. Now, I'm probably being a bit too rigorous here in relation to writing this out, yeah. Okay? This becomes then it's just a product of when we know that they're not independent of each other, yeah, because it was without replacement, without replacement, which basically means after you select the first battery, you've got so many chances out of 10, yeah, for the first battery, but you don't put it back in. So when you go to select the second battery, there's only 9 batteries left. And then when you go to select the third battery, yeah, there's only 8 batteries left, if that makes sense. So we know now that without replacement means that there's dependence. So we need to calculate this is now just the product of the 3 probabilities. So the product, it's going to be the probability that the first is defective. Well, that's equal to, okay, well, how many defective batteries have we got? We've got 3 chances out of 10, okay? Now, the next one, the probability that the second is defective, okay? Well, we now only have 9 batteries left in the box, and we didn't put the first battery back in. So there's only 2 defective batteries left in the box because the first battery we took out was defective. So now you've got 2 chances out of 9. And then the probability that the third is defective, well, now we've only 8 in the box, okay? But the previous 2 batteries were defective, so there's only 1 defective battery left, so it's 1/8, yeah? So now the probability is the product, so it's equal to the probability of 3 defective batteries, okay, is equal to 3/10 times 2/9 times 1/8, yeah? Okay, and whatever the hell that works out at, yeah? Okay, that's that probability. Technically, now you can put your fingers in your ears if you want for this, yeah. If I was writing this down, I really have to write this down as the probability that the first is defective and the second is defective and the third is defective, because this is the multiplication rule, and because there's dependence, this becomes the probability that the first is defective times the probability that the second is defective, knowing that the first was defective, yeah, times the probability that the third is defective, knowing that the first was defective and the second was defective, if that makes sense. Yeah, that's what we've effectively calculated here. So the probability of the first being defective, well, how many batteries are there? There's 3 defective batteries out of 10, so you've got 3 chances out of 10. Okay. The probability that the second is defective, knowing that the first one was defective and wasn't put back in. Okay, that's all that's going on here. Well, that leaves 2 defective batteries out of 9. And then the probability that the third is defective, knowing that the first was defective and the second was defective and none of them are put back in, which leaves us with only 1 defective battery out of 8. Okay, but mathematically, that's how we'd write it down from a conditional probability perspective. Conditional probability. Okay, but as I said, put your fingers in your ears for that. This is a little bit probably too technical, yeah. Okay? But that's probably the right way to approach this, yeah. Okay? In relation to an answer. Nicole. Okay, no problem, Nicole. Yeah, so hopefully that helped you out there, guys. I'm just wondering when the exam is the exam tomorrow? And then my second question then was going to be, what time is the exam at tomorrow? Okay. There seems to be a bit of a delay here in relation to. Okay, maybe I'll just type that in there. Yeah. Okay. just typed in is the exam tomorrow, and anytime between 11 and 12. Okay, right, that's good, yeah. Okay. Right, look, I think we're about an hour into this here now, yeah, 59 minutes and 41 seconds, yeah. So will we leave it there? Is that okay? So what I'm going to do, so just guys, thanks for dropping in. I suppose that's what we should really say. Yeah, thanks for dropping in. All the best tomorrow. With the MCQ. Okay. If you have any questions between now and then, okay. So if you have any questions between now and then, just drop me an email. Okay. Okay, guys, I'm just going to finish this off here now. I'm just going to close this down. Once again, thanks for turning up and coming along. Jem, I see you're still there on Teams. Thanks very much for dropping in. Yeah, Lena, thanks very much. Jessica, thanks for coming along. Saeed, thank you. And Charles, thanks for dropping in. Okay, bye, guys. Take care. So now, where do I go? I go there to end that stream. End the stream now.